everybody. Last DL, we took some data that allowed us to calculate the heat capacity at constant volume for a certain substance. This DL, we're going to do something similar, except instead of holding volume constant, we're now going to hold pressure constant. But why should this change our results? Well, I'm not going to give you the whole answer, but I will give you a part of it. Remember when we did the constant volume measurement, that the pressure of the gas increased as we added energy to it. But we now want to do the same experiment with the gas at constant pressure. So what do we have to change in order to allow the gas to remain at this constant pressure? Well, we have to allow its volume to change. And we know that interesting things happen with gases when we allow their volume to change. As before, there are 4 numbers you're going to be needing to write down at every step. Those numbers are temperature, pressure, volume, and total energy. I'm going to turn my camera onto the simulation again and let you collect the data yourself as I add the energy. All right, everybody. Here's our simulation for constant pressure. Notice that the volume of the container is fluctuating up and down a little bit. As we add energy, we expect this volume to change more dramatically. Here are the initial values that we care about. Make sure you write them down before moving on to the first step. We're going to add 2 times 10 to the negative 19 joules of kinetic energy at each step. As we expected, the volume has increased somewhat. All right, I'll add the next step. Let's add the next step of energy. And we're now going to add 2 more. As before, you can always rewind and pause the video in order to collect the data that you need, but make sure you're able to fill out the table before moving on.